Take-home quiz. Here we go. Good old Anne. I think here, it looks like flowing out, I have 0.75 amps and 0.53 amps. That means I must have that flowing in. I only have 0.96 amps coming in, so I think it's going to be this minus 0.96. I think the magnitude is at 0.32. Is that correct?
Yeah.
And then direction, is it flowing in or out? Now, I didn't really, looking at this, there's no easy way for the direction if you said towards the center or something along those lines. So you be your own judge if you figured out that the current is going that way. Okay. Down? Sure, I'd take down. 1 mark for each of those. 4 resistors and a power supply are arranged to form the circuit below. What's the total resistance of this circuit? Just in glancing at this question, without even reading part A, because I don't have 2 things anywhere, I don't have amps anywhere, already I was thinking I'm going to have to rewrite this sucker probably. So since they want total resistance, the nice thing is I was going to have to do that to answer anything anyways. Okay. These 2 are in parallel, so I would probably do something like this. 1 over R parallel is 1 over 10 plus 1 over 10. That's 2 over 10. When I flip 2 over 10, I get 10 over 2. Is R parallel 5 ohms? And so R total is 20 plus 5 plus 20. Is R total 45 ohms? So I would probably do something like this. I would give you 1 mark for that. I would give you 1 mark for that, and then 1 mark for the answer. But if you got the answer right, I'm fine with that. What's B asking me to find? Total current leaving the battery. So I am going to re-sketch this just a little bit then. So right now I have, oh, you know what? I don't need to re-sketch it because I know R total is 45 ohms, and I know total voltage, that's going to be the battery. They told me that, 15 volts. So I can find I total. It's going to be V total over R total. So although I was going to sketch it, I think I can get away with doing this all just purely with Ohm's law. So it's going to be 15 divided by 45. You get 0.33 repeating amps. I would probably do something like this. I would give you a half mark if I saw that written somewhere, a half mark for that, and then 1 mark for the answer. What's the voltage drop across R1? Oh! If I know total current, the question falls apart. So I have 0.33333 amps leaving right there. That means there's 0.333333 amps leaving right there. So I'm going to go 0.333333, a few of those, times 20. You get 6.67?
Yeah.
I would take 6.7. 6.66, I would say, hey, be a little careful in your rounding off, please. So for 2 marks, if I saw somewhere this idea of V equals IR, if it was obvious that somewhere you'd gone 0.33 repeating times 20 and you've gotten 6.67 volts. By the way, how many volts in V1? How many volts in V1? The answer to part C, 6.67. How many volts do I lose in R2? Got to be the same thing because the total current goes through there. Just give me 1 second. Pause the video. Just for the record, though, how many volts was here? 6.67. How many volts here? Because it's the same R and I total is going through it, 6.67. So another question I could have said easily would have been, how many volts right there? 20 minus 6.67 minus 6.67. That's how many volts there. How many volts there? Lots of options. Or I could have said how much power in R4. Trying to give you an idea of questions I might ask. Does the next one have a terminal voltage question to it? Yes. Good. There is going to be a terminal voltage question on your test, maybe 2. Don't let terminal voltage freak you out. All terminal voltage is the EMF minus whatever you lose there. Or all EMF is the terminal voltage plus whatever you lose there. I can go either way. What's the terminal voltage of this cell? Did they tell me anything else anywhere? Do I know 2 things anywhere? I'm going to have to rewrite this. So I'm going to go 1 over R parallel is 1 over 10 plus 1 over 10. Oh, same answer. R parallel is 5 ohms again. Yes? R total is 5.7 ohms. Is that correct? Okay. So that's the terminal voltage is going to be the maximum theoretical EMF minus, don't write this next bit down, the voltage loss going through the battery, but V equals what times what? So instead of writing that, I'm going to say capital I times little r. I don't know total current yet. Okay. I got R total. I total is going to be V total divided by R total. The maximum is 15. I'm going to use the 15 because R total is including the 0.7. So it's 15 divided by 15 divided by 5.7. It's going to be a yucky number. Did you get I total of 2.63 blah, 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 blah? And that's what's going to end up over here. It's going to be 15 minus 2.63 times 0.7. 15 minus answer button times 0.7. You got a terminal voltage of 13.2?
That seems like a low answer.
Yeah.
Off a stick figure.
So if you got that, I'd give you 4 out of 4. Otherwise, for part marks, I'd probably give you 1 mark if I saw that, 1 mark if I saw that, 1 mark if I saw total current, and then 1 mark for figuring the terminal voltage. So how many volts do you lose traveling through the battery? Right around 1.8. That 1.8 varies. If I total changes, well then the voltage drop, the terminal voltage changes. What doesn't change in this question? The EMF. That's constant. Suppose the bottom 10 ohm resistor is removed. Terminal voltage will increase, decrease. Sorry?
What did you say?
So when we remove that bottom resistor,
Yeah. It'll decrease.
we remove a resistor in parallel. When we remove a resistor in parallel, what does that do to R total? Okay? R total increases.
Yeah.
So if R total increases, I total, if this got bigger, what happened to I total? Decreases. So I times little r decreases. So V equals E minus I times R, my terminal voltage. If this number got smaller and my 15 doesn't change, what happens to my terminal voltage answer? It's going to get... So for a proof, if you said something like this, or if you actually crunched it, if you actually crunch it as an answer, you'll get 10 plus 0.7. There's your R total. You'll get 15 divided by that. There's your I total, and so it's going to be 15 minus that answer times 0.7, and that you're telling me 14.02, 14.0? If you solved it, I would give you full marks as well. So we did it both ways, Sarah. I did it analytically by, that's why I said that understanding of knowing, and it's strange, but adding a resistor in parallel lowers our total. Removing a resistor in parallel raises our total, which would then decrease I total, which would then, and take it from there. Is that okay? Number 4, which I need to move to the next page to go with the question. What is the power dissipated in the 16 ohm resistor? This gives you an idea of a nice 7 mark kind of question. Why is this one so tough? Because they didn't give me any amps or anything. There's no two things. I'm going to have to rewrite this. So my skiing tricks come to a halt here. I'm going to combine those two, so I'll do that right nearby. 1 over R parallel is going to be 1 over 16 plus 1 over 25. R parallel is going to be you get R parallel is 9.7561? And I'll carry 5 sig figs. There's a 9 there and a 0 there, so I'll make that 0 a 1. 9.7561. 9.7561 ohms. R total is going to be 7 plus 9.5761 plus 1. So plus 7 plus 1. Could have done that in my head. I get 17.7561. Ohms. Why is that so helpful? Because now I can tell you I total is going to be V total over R total. It's going to be 15 divided by 17.7561. Kind of hoping somewhere along the way this might work out nicely, but we'll see. Nope. 0.84478. And again, I'm carrying the extra sig figs, Kieran, because I know I'm going to be using this. I don't want to round off right to there because that's going to introduce a lot of error into my calculations. Alrighty. That's amps. Thank you. I've done that a bunch of times, this unit. I'm going to label so I know that that is 0.84478 amps, and that is 0.84478 amps. Lyndon, is this the one? No. Were you the 1 times table? No, it was Irfan. It was, no. Irfan. I did it again. My other block sits there. Munir. Long story.
His name is
Times 1. Did you actually type times 1 on your calculator? Just now? Oh, okay. So the voltage here is going to be 8.4478 volts. Here I'll multiply this by 7. How many volts do I lose there? And I get 5.9135. 5.9135 volts in that resistor. Now I can figure out how many volts are going through this resistor. It's going to be 15 minus that voltage, answer button, minus 0.84478 volts. This has to be 8.2418. Volts. How many amps is that? Divide by 16, and I get 0.51511 amps. Whew! Now, power equals, you can either go I squared R or you can go V times I. The voltage lost in there was 8.2418. And the current through there was 0.51511. Have I made a mistake, or are these numbers correct? Because these numbers look yucky. Do you get 4.25 watts? Am I wrong, or have I made a dumb mistake, or is somebody else getting that?
Nathan is nodding yes.
Nate's nodding yes. Got that too? So, power equals 4.25 watts. Now, if you round it off along the way, you could be way off, which is why I use the answer button or carry extra sig figs whenever possible. For full marks, I would probably do something like this. I would give you 1 mark if I saw R parallel, 1 mark if I saw R total. I would give you 1 mark if I saw I total, that's 3. I would give you 1 mark if I saw that you'd found that voltage. I would give you 1 mark if I saw that you'd found that voltage, that's 5. I would give you 1 mark for finding the current or the voltage in there, that's 6. And then I would give you 1 mark for the answer, that's 7. And that, my angels, is the quiz. Can you give yourself a lovely score out of 20-something something? 23, apparently.
I just did corrections right now.